Welcome to Baskaran's Think Differently Top 9. If you have not yet subscribed this channel, kindly subscribe immediately. Top 9 is an interesting puzzle and at the same time very simple puzzle. What are we to do? Look at this diagram. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 smaller squares. You have to fill these 8 squares by the 8 numbers 1, 2, 3 up to 8 such that condition 1, each number should occur once and exactly once. Condition 2, successive numbers should not occur in neighbouring squares. Successive numbers? What are successive numbers? 1 and 2 are successive numbers. 2 and 3 are successive numbers. 3 and 4 are successive numbers and the like. And what are neighbouring squares? For any square, a square which comes above or below it is a neighbouring square. A square which comes to the left or right is a neighbouring square. A square which comes along the diagonal next to it is also a neighbouring square. So, for this square which comes below, which comes along the diagonal next to it are the neighbouring squares. Similarly, for the other squares. Now, how to solve this puzzle? You may think that you can start at random. If you start at random, you will most probably end up in trouble. You have to think differently. What is there to think, you may ask? You have to think. Are the 8 squares equally problematic? No. For this square, there are 3 neighbouring squares. And for this one, you have 1, 2, 3, 4. 4 neighbouring squares. And what about the middle square? 1, 2, 3, 4, 5, 6. It has 6 neighbouring squares. So definitely, all the squares are not equally problematic. The squares which have less neighbors will be less problematic and more neighbors will be more problematic. And what about the numbers? Are they equally problematic? No again. Why? One has a successor, one has no predecessor. Similarly, 8 has a predecessor and 8 has no successor. For the other numbers, they have both predecessor and successor. Therefore, the rest of the numbers from 2 to 7 are equally problematic. They are more problematic. Now, what to do? Simple common sense. Fill the most problematic squares by the less problematic numbers. That way, 1 and 8 should come in the middle. If you put 1 and 8 somewhere else, definitely you cannot solve this puzzle. So, put 1 here or here. I put here. And 8 comes here. Now, where can 2 come? For 1, all these squares are neighbouring squares. So 2 should not occur there. 2 can occur only here. Right? Now, you should not go for 3. You should go for 7 because we already put 8 here. And where can 7 come? It can come only here. So, we have filled 4 squares. The remaining are 4. Now, where can you put 3? 2 is here. So, these 2 are neighbouring squares for 2. So, 3 cannot come there. 3 can come either here or here. Wherever you want, you can put. I put 3 here. And the next, we should go for 6 because we already put 7. Where can 6 come? 6 cannot come here. It can come here or here. And you cannot put in any of these 2 squares also because we have to think about the next step. If you put 6 here, then the remaining numbers 4 and 5 should come here, and the two successive numbers 4 and 5 will occur in two neighboring squares. So you cannot put 6 here, therefore we have to put 6 here. Now 4 will find its own place. You cannot put 4 here. So 4 has to come here and 5 has to come here. You have filled in all the 8 squares with all the 8 numbers such that each number occurs once and exactly once, and successive numbers do not occur in neighboring squares. Think different.